Okay guys, we're going to do the video for 1-19 similar triangles. Before I get started, when we were looking at our viewership data, we were noticing that there's people watching these videos from all over the world. Really, really cool. Way more than what we expected. If you can, I think I have it turned on. Leave some comments at the videos. Tell us what you're looking for. Tell us if it's helpful. Okay, tell us where you're from. All really, really cool stuff. All right, so let's look at the first video, first example for similar triangles, right? But before that, I just want to go over a couple of rules. Okay, so the idea of similar triangles is that they are similar by angles. So in other words, right, the angles are the same, but the size is different. So let's take a look at this orange guy and this green guy. We could look, if I put them on top of each other, we could see that they're not at all similar, right? They don't match up in any way. Watch the difference when I put them on top of the blue. Okay, you can see that it lines right up. Right, now these are supposed to be pretty parallel. When I cut it, it came out a little off. I just want to compare the angles to show you that when we compare the angles, they're pretty close. So this is 45 degrees when I put them that way. And this is 45 degrees. Okay, I could compare another angle. And this is about 20 degrees. Okay, and this is about 20 degrees. So it's a little bit off where I cut them at the bottom. So now let's take a look at a couple of examples. All right. The first example. Right, I know these parts here are similar. I know the triangles are similar because I have parallel lines. When I have parallel lines, right, these thanks to alternate interior angles and those different types of angles that we learned in previous videos, right, it forces these triangles to be similar. So what I'm going to do from there is I'm going to set up a proportion. A proportion is just basically two fractions that are equal to each other. All right, and I'm going to start here and end there. So this is going to be x over 2 and 3 over 6. So I'm going to start that. X over 2, 3 over 6. Notice the way my hand is going in the same direction. All right, start, finish, start, finish. So x, oop, my marker went dead. Let's grab another one. So x over 2 equals 3 over 6. Okay, I'm going to cross multiply and solve. So I'm going to get 6x equals 6, divide by 6, divide by 6, and x equals 1. Watch, it's not the only way you can set them up. There's a couple of ways you can set them up. So this time I'm going to go start, finish, start, finish. So 3 over x, 6 over 2. 3 over x, 6 over 2. When I cross multiply those, I get 6 equals 6x, and divide by 6, divide by 6, and I get x equals 1 again. I'm just trying to point out that as long as you keep the direction that you're going in constant, for the most part, this will work. All right, let's take a look at the next one. Example number 2. All right, so here I have this whole piece right here, or it's these two put together, then I have this part and this part. I cannot compare one of these parts to these sides added together. I need to have them all to be the same kind of category or same type of thing, right? So like I have to compare apples to apples and oranges to oranges. So if this is an apple, this is an orange, right? I can't compare them. But what I can do, if this makes sense, is subtract an apple from an orange to get an apple. And that's what I'm going to do. Now what I'm going to do is I'm going to think ahead, right, in the way I set up my proportion, and notice that here, right, I can reduce those. If I can reduce, I don't need a calculator anymore. So that's what I'm going to do. I want to try to limit my need for a calculator as much as possible. This way, it's less likely I'm going to make like a calculator mistake by inputting. So this is 7 over 3 equals x plus 6 over x. I'm going to cross multiply, so that's 7x equals 3 x plus 6 distribute. So I got 7x equals 3x plus 18. I am going to subtract 18. Whoops. Oh, almost made a mistake there. Look at that, what happens when I'm not careful. Subtract 3x. I get 4x equals 18. Divide by 4. And x equals 9 over 2. Okay? All right, I hope you guys, that kind of was clear. Let's try this last one here. All right, so this example is kind of similar. But this time, right, I have this whole piece here, but it's really difficult for me to try to subtract x from there. I mean, I can do 20 minus x, but I think that's making life a little bit harder than it needs to be. What I can do is I can add this, and I can make this 16. So now I can compare this orange to that orange, and that apple to that apple, and I can set the proportion up that way. We don't need this 4 anymore. I used it to get this whole piece. I'm going to go, let's see, 20 over 16 equals x over 12. Then I'm going to reduce that. 5 over 4 equals x over 12. Cross multiply. Here we go again. That reducing, I did not need a calculator anymore. And I get 60 here. Right? I'm going to divide. And I'm going to x equals 15. Okay, guys? Like I said, the whole thing is just make sure that the direction is constant. So 20 over 16, x over 12. Start, finish, start, finish. All right, guys. I hope you guys found this video helpful.